Hello everyone, welcome to the Telecommunication Engineering Laboratory 5. In this lab, we will learn about the noise in analog communication system. The objectives of this lab are to understand the behavior of the noise in analog communication system. The second one is to understand the affectations of the noise in analog communication system. And the last one is to be able to handle the unwanted noise. Okay, we have three objectives in this lab. So what is the noise? Basically, the noise is the unwanted signal that is introduced in any system or any circuit. The noise can result in the disturbance or the interference or the distortion of the original message or original signal. The impact of the noise can reduce the performance of the communication system, or it can also reduce the inaccuracy of your signal. Okay, in general, the noise is some signal which has no pattern here and no constant frequency or no constant amplitude. Is it quite random or unpredictable? So that means the noise is very random. Okay, maybe this. And in the world, there are many types of the noise in communication system. For example, the thermal noise, short noise, transition noise, or the resistance effect noise, or the noise from mixer generator circuit, and many more. Okay. So in the communication system, the system normally contains the first one, the signal generator, or we can call it transmitter. So this part used to generate the original message or original signal. And then the signal will go through the channel or medium, okay, which is basically the medium for transmitting the signal. And the third part is the receiver, which is used to receive the signal from the medium. Okay, basically we generate the signal here and send it through the medium or channel, and then we will get the signal at the receiver here. Okay, in communication system, the noise can be generated at any part, okay, in any part of the system. Maybe the noise generated in this part, maybe it is generated in channel, or sometimes it may be generated in receiver. Okay, but there are two main types of the noise. The first types of the noise is the noise produced by the internal source. Okay, and the second one is the noise produced by external source. Okay, from internal source, that means here the noise produced by the internal source means the source of the noise is from inside the circuit. Okay, for example, the noise generated by the electronic circuit. Maybe we have electronic circuit RLC here, and this circuit can generate the noise to the signal. And maybe here we also have the circuit, maybe low pass filter or band pass filter, or something that can generate the signal, the noise. Okay, but if the noise is produced by the external source, it is called the external source noise. Okay, that means the noise may come from from other signal or other wave. For example, if we want to transmit the signal with 5 gigahertz, if anyone transmit the signal with the frequency of 5.01 gigahertz, okay, that means this signal maybe generate the noise to our signal. Okay, that means the source of the noise is generated from outside. Okay, and the noise generated by an internal source usually occur at the transmitter or the receiver, but the noise produced by an external source usually occur at the channel. Okay, and mostly the noise generated at the signal generator or the receiver can be easily eliminated by using the electronic circuit. Okay, but in the channel, it is hard to control the noise. It is also hard to protect the noise or protect the signal from outside that may interfere our circuit. Okay, because everyone transmits the signal through the air. Okay, so it is hard to protect the noise from other signals. And when we get the signal at the receiver, maybe for example, we send this signal, the noise come to our signal. Maybe at the receiver, we will get like this. Okay, and what we have to do is we have to recover the signal to the original message. Okay, so let's move on to the experiment. For the experiment 1, construct a circuit according to the block diagram shown in figure 1. Then use the noise generation module to display the noise signal on the oscilloscope. Okay, here you just generate the noise and display on the oscilloscope. Okay, also you have also to observe the frequency spectrum of the noise. Okay, so you have to do 2 things in this lab. The first one show the noise, and the second one show the amplitude, show the frequency domain of the noise. Okay, and for experiment 2, construct the circuit according to the block diagram shown in figure 2. In this experiment, you use the adder module to add the noise to your message. Okay, and then display it on the oscilloscope. And also display the frequency spectrum of the noise with the message. Okay. And the last experiment 3, construct the circuit according to the block diagram shown in figure 3. So Firstly, you have to construct a double sideband full carrier. Okay, here at the moderator, you have to construct the double sideband full carrier, which is similar to experiment 3. Okay, sorry, laboratory 3. Okay, here you get double sideband full carrier, and then at the demoderator you have to here is your demoderator here. So before you go to the demoderator, you have to generate the noise, okay, and pass it through the amplifier, okay, and go to the adder with your double sideband full carrier, and then do the moderator the same as you did in lab 3. Okay, here, so lab 3. So, and then display the signal on oscilloscope. Okay, display the signal here on oscilloscope. And here at the noise generator and amplifier module, you have to adjust the tunable of the noise. Okay, adjust it to the maximum value. And then at the buffer amplifier module, you also adjust the tunable here. Okay, adjust this one, and this one until you see the distortion of the original message. Okay, and then determine the threshold of the noise amplitude that caused the distortion on original message. Okay, show when you see the distortion of original message. Okay, that's all of the experiment today, and goodbye.